Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about one chemistry experiments. And the aim of this experiment to determine the number of molecules of water of crystallization. You know the water of crystallization? Here you can see in this formula X is 2. So our aim to find out how many water of crystallizations in ferrousammonium sulphate, 20 gram of which have been dissolved per liter, provided approximately N by 20 KMnO4 solution. For that experiment, you need burette, conical flask, dropper, glass rod. Chemical requires ferrous sulfate solutions, potassium permanganate KMnO4, and more salts. What is the theory behind it? Standardize KMnO4 solution by titrating against N by 20 ferrous sulfate solution. Then you need ferrousammonium sulphate is titrated against the standard KMnO4 solution and then calculate the value of X. So you need to know about the chemical equations. So this is the chemical equations. 2 moles KMnO4 plus 3 moles sulfuric acid, it gives 1 mole K2SO4, 2 mole MnSO4, 3 mole H2O, 5 oxygen, and then ferrous sulfate dot NH4 whole 2 SO4 dot 6 H2 plus H2 SO4. This oxygen, it gives ferric sulfate and ammonium sulfate, 30 water molecules. You have to multiply it with 5, and this is the final equations. 2 mole KMnO4, 10 mole ferrous sulfate, ammonium sulfate, 6 H2O, 8 moles H2SO4, it gives K2SO4, 2 moles manganese sulfate, 5 mole ferric sulfate, and 10 mole ammonium sulfate, and 68 water molecules. And this equation is balance equation. Now, first titration, ferrous sulfate against KMnO4. In this titration, you have to use KMnO4 act as self-indicator. So, no need to use any indicator. KMnO4 act as a self-indicator. So, how you know the end point? With the appearance of light pink color. What is the procedure? You have to follow these 5-step procedures. Rinse and fill the burette with KMnO4 solution. Pipette out 20 ml of ferrous sulfate solutions into a conical flask. You know the conical flask. And then add 1 test tube of dilute sulfuric acid. Not egg, add. Then add KMnO4 solutions dropwise with shaking. At the end point, light pink color just appears. Repeat the titration to get a set of 3 concordant readings. So observations, volume of N by 20, ferrous sulfate taken each time 20 ml. So you have to do 5 experiments, write it down, initial reading from the burette, final reading from the burette, and volume of KMnO4 solution in ml in each steps, and then take the average concordant volume VML. Then do the second titrations, ferrousammonium sulphate against KMnO4. So again KMnO4 act as a self-indicator. How you know the end point? Appearance of light pink color. You have to follow the following steps. Rinse and fill the burette with KMnO4 solution. Pipette out 20 ml of ferrous ammonium sulfate solution into a conical flask, and then add 1 test tube of dilute sulfuric acid. Then add KMnO4 solution dropwise with shaking. At the end point, light pink color just appears. Repeat the titration to get a set of 3 concordant reading. Make the observation table. And initial reading from the burette, final reading, and volume of KMnO4 solution in ml, concordant. So concordant volume x ml. Then do the calculation. From first iteration using normality equation, N1 V1 is equal to N2 V2, ferrous sulfate solutions and KMnO4 solution. So you know the ferrous sulfate solution N by 20. Each time you have taken the 20 ml. Now KMnO4 solutions, you have taken the volume. So take the average volume and you have to calculate the N2. So N2, that is normality of KMnO4 solutions, N by V. Then do the second titrations calculations, again using normality equation N1 V1 N2 V2, ferrous ammonium sulfate solution and KMnO4 solution, N1 into 20 N by V into X. This is very important point here. So N1, that is normality of ferrous ammonium sulfate N by V into N by 20, and strength of anhydrous ferrous ammonium sulfate is equal to normality into equivalent weight. So N1 into 280, because the equivalent weight of anhydrous salt is 284. Then now using the relation molecular weight of ferrous ammonium sulfate, strength of anhydrous salt, molecular weight of ferrous sulfate, and strength of anhydrous salt. So hydrous salt and anhydrous salt. So this is the mathematical formulations. From the above relation, the value of X can be calculated. Now the precautions. You have to follow all rules and regulations of the experiments, and you have to take the following precautions. First precaution, the apparatus should be cleaned and dried. The second, always place the KMnO4 solution in the burette and read the upper surface of its meniscus, as the lower one is not clearly visible. And about 20 milliliter of dilute sulfuric acid to a solution before titrating with KMnO4, because of less amount of added, then brown precipitate of hydrated MnO2 is formed. And never run large amount of KMnO4 solution at a time, otherwise a brown precipitate of hydrated MnO4 is formed. And then you have to write the results. Ferrous ammonium sulfate crystal have molecules of water of crystallization. So whatever the water molecules of crystallization, you have to write here. So friends, I hope this video will be helpful to you. If you like this type of video, then subscribe my channel, and thanks for watching.